So we have 200 kilograms of tin at 100 degrees Celsius dropped into 500 kilograms of water at 10 degrees Celsius. Find the final temperature, and the specific heat capacity of tin is 230 joules per kilogram degrees Celsius. So essentially what we have is we have a metal. So I can do, let's say we have, we have a metal, and we have water. So water, I'm going to do it blue. This is blue. Essentially, what we know is we know the mass of this, we know the temperature of this, we know the mass of the water, temperature of the water. But what's going to happen is we're going to take the metal and we're going to submerge it or drop it, either way, into this water. And what we want to know is what is this final temperature of them two combined. So that's essentially what we're going to do with this problem. So I'm actually going to, for tin, I'm going to do it in red. Water, I'm going to do it in blue. I'm going to write out our givens. So we're going to have, what I do is a little chart for this. I just think it makes it easier. So we have tin, it has 200 kilograms is our mass, 100 degrees Celsius is our temperature initial. Let's drop into 500 kilograms of water at 10 degrees Celsius, find TF. And then we also know the specific heat capacity. 230 joules per kilogram degrees Celsius is our specific heat capacity. I should be an artist. Now we have all our tin values. Now we need our water values that it gives us. So water, it's going to tell us it's 500 kilograms. So 500 kilograms is the mass of H2O at 10 degrees Celsius. So 10 degrees Celsius is our TI. It does not tell us the specific heat capacity of water, but if you just look it up on the chart, it's understood, since it told you that it's water, that it is always this value. It's kind of like gravity. You always know what gravity is. Water is always 4,186 joules per kilogram degrees Celsius for its specific heat capacity. So this is my little table. Our unknown is going to be the temperature final. So TF, you can do it in a different color if you want, because it's not water or tin, it's actually both of them. So I do it in a different color. Our equation is very important right now, that you understand what's going on. So since this metal is being dropped into this water, and they have to equal each other right here, their final temperatures, that means the energy of this metal has to equal the energy of this water. That way they can come into equilibrium, which is balance. So, an important thing is you need to know which one is losing energy and which one's gaining. Because that one, the one that is losing is going to be negative. So the one that starts with a high temperature, or the higher temperature, is going to be the one that's negative. So if you look at the TIs, 10 degrees Celsius, 100 degrees Celsius, 10 is the one that's going to be losing energy. So what that means is its energy, which remember we write as capital Q, is going to be negative. And it's going to equal the positive Q of the water. We don't have the values of Q, so what I'm going to do is I'm going to expand this. If you look, we know we have C and TI, so I'm going to use Q equals MC delta T. So instead of writing Q, I'm going to substitute in, don't forget your negative, MC TF. I guess I could write my TF as green, minus TI. And it's going to be equal to our MC, notice this one's positive, TF minus TI. At this step, I actually have you plug in numbers, just because my math skills are a little soft when it comes to this problem, so I actually have you plug in the numbers because it makes it a whole lot easier to do the algebra. I'm not worried about units really right now because it's asking for final temperature. Temperatures in degrees Celsius, so our answer has to be in degrees Celsius. If you want to, you can just ask me in class and I'll be more than happy to show you how to do that. So I'm just going to plug in. Notice I color coded, so it's going to be real easy. All the red should be over here. All the blue values are over here. So 200 kilograms, 230 joules per kilogram Celsius. We still don't have TF, and our TI is 100 degrees Celsius. This is going to equal, now we're going to use blue values, so water, 500 kilograms. And then we're going to do TF minus TI, which we know the value of TI is 10. So what I'm going to do is I'm going to distribute these values. And I'll show you what I mean by that. So I'm going to take 200 times, negative 200 times 230, and then I'm just going to solve that value, and then it's going to be multiplied by the TF minus 100 degrees Celsius. So 200 times negative 230 is 46,000. So we're going to have negative 46,000. It's important that you understand what we just did. We just multiplied these two, and we still have it multiplied by TF minus the 100 degrees Celsius. I promise after this step I'll move it so you can actually see it. Then we're going to also do the same thing on the other side. We're going to take this 500 times 4,186. Make sure you're taking 500, not 50. I did that last time, so that's why this is attempt number 2. So we have 209, 3 with 3 zeros, and then it's going to be multiplied by the TF minus the 10 degrees Celsius. So what I'm going to do is I'm going to rewrite this. Same thing I have down there. I'm just going to rewrite it. That way it's a little bit easier to see. Up above. So we're going to have negative 46,000 times TF minus 100 degrees Celsius. That's going to equal 2093 with 3 zeros times TF minus 10 degrees Celsius. So now what I'm going to do is I'm just going to distribute the number in front, or the coefficient. So I'm going to take this number, distribute it here, and distribute it here. And I'm actually going to do it on both sides. So we're going to have negative 46,000 times TF. It's actually pretty convenient because it's just going to be negative 46,000 TF. This is going to get rid of our parentheses, which is nice. Notice I changed it to green because now it's labeled as TF. And then I'm going to multiply negative 46,000 times negative 100 degrees Celsius. And that is actually going to make it, the negatives cancel out to become positive. When you multiply those out, you'll get a big number like that. Now we're going to do the same thing on the other side. So I'm going to take this, like 2,093,000, and multiply it by TF, and we will just get 2,093,000 TF. And we're going to take it times the negative 10 degrees Celsius, and we're going to get just one more zero on it. So now what we're going to do is we're going to combine our red and blue together, and then we're going to combine our greens together. I like the green to be at a positive value, so what I'm going to do is I'm going to add this way. That way it just makes it a little bit easier. I like to deal with positives, so I'm going to add 46,000 to both sides. Notice it cancels out on the left. On the right, we're just going to add them together. So we should get 213, 9, 3 zeros, TF. Minus our 209, 3, 1, 2, 3, 4. And this is still equal to our 46 number. Now we're going to get our numbers together, because neither one of them have a label. So we're going to just add this to the other side. These cancel out. We're going to add these together, and what's going to happen is we're just going to have this value, this value. So we're going to have, it doesn't matter if this is blue or red, I'm just going to write whatever's in my hand. So 2, 5, 5, 3, 4 equals 2, 1, 3, 9, 0, 0, 0, TF. So we're going to divide TF by the number in front of it, by its coefficient. So we're going to divide this by both sides. And this is going to get us what TF's value will be. Notice it does not tell us what units it is in, but if you just look at the problem, we'll figure it out. So this cancels out. You should get 11.94. And since it's talking about final temperature, temperatures in degrees Celsius, this is going to equal TF. That's how you do it. Are you cleaning that?